Good morning, everyone. Welcome to yet another training session of High Fluids Engineering. Our topic for the day is OISD Standard 116 Fire Protection Facilities for Petroleum Refineries and Oil and Gas Processing Plants. Let's meet our trainer for the day. Our trainer for the day is Ms. Pia Judith. She is working as a lead process safety engineer for High Fluids Engineering. She has 14 plus years of experience, and the key areas of expertise includes fire and gas mapping, QRA, HAZOP, and emergency response disaster management plan. Some of the major projects she has accomplished are Rapid Risk Assessment Study for IOCL Mathura Refinery, HAZOB and QRA study for IOCL 18 locations POL terminal, FNG mapping study for ONGC Hazara Gas Processing Plant. We heartily welcome you to the training session, ma'am. Thank you for joining us here today. I also welcome every participant for this training session. If you have doubts, please ask your doubts. You can post your doubts in the link that is given in the chat box of the YouTube. And if you want to register for the assessment to gain certificates, you can register yourself. The link of the same is given in the chat box. Without further ado, we can move on to the training session. I kindly request Pia ma'am to take the session forward. Thank you.
Yeah, thank you. Thank you for the introduction, Ma. Yeah, good morning, all. So, can you move on to the first slide? Yeah, yeah. So, today we are going to have an insight into this fire protection facilities for petroleum refineries and oil and gas processing plants. So, the agenda or otherwise, the objective of this presentation is to provide you an insight what it is there, which is there mainly captured in this OASD standard 116. Can you move on to this next slide? So within this 1 hour, we can't capture all the significant points which is there in the OASD. So which are very some of the very few significant points are like presented in this particular presentation. So can you move on to the next slide, ma'am? You want me to do or Anupama? Yeah. Is yes. Actually, the page is not fully visible to me. How about to others? Yeah. So, what is the scope of this OASD 116? This particular standard is like to provide the minimum design criteria and to detail about the what are all the various fire protection systems has to be provided with respect to this petroleum refineries and oil and gas processing plant. This particular OASD 116 is applicable only for this petroleum refineries and oil and gas processing plants. So petroleum refineries means whatever the refinery which is coming as like when crude is coming and it is transferred to the product as well as byproduct in various stages. It is called as petroleum refineries, and oil and gas processing plant means so whatever the oil and gas processing plants like POL terminals and other things. So all those things are like which is not included. So what are all the things which is included in this particular scope and which is not is a part of the scope is like covered is presented over here in the third point. Like the standard which is does not cover the facilities since because if it is locating outside the plant. If it is locating very far away from this plant like LPG mounted storage bullet like LPG bottling plants and as well as LPG handling areas, LNG storage depot terminals, lube oil blending plants. All those things is not a part of this particular standard. So to capture this particular standard, to capture we have to refer the other OASD standard, which is like OASD 114 for LPG handling areas and 169 for mounted storage areas and like 117 for this petroleum depots and gas gathering stations and all. We have to refer this OASD standard 189. So all the other facilities will be the part of this particular 116. If in some cases like if you have this particular OASD facility like like a gas or oil and gas processing facilities near to the premises or just located like within the premises of the refineries, then this particular OASD standard is applicable for these facilities also. So then, what are all the major definitions will be the part of this OASD is like it will describe about what is petroleum refinery and what are all the oil and gas processing plant. Anupama, can you move on to the next slide? Yeah, and all those things. Oil and gas processing plant, what is flashpoint, and what are all the classic, what are all the types of fires, what are all the types of petroleum products, and what are all the types of heated products. All these things are defined very clearly in this particular standard. In order to capture one exclusive point which is mentioned with respect to this oil and gas processing plant is this particular standard is not applicable for the upstream facility of the Christmas tree. So, under oil and gas processing plant, this particular facility won't be a part of this OASD. So, it is not covered in this OASD. So, what are all the types of fires? So, why? Because all these definitions are provided. Okay, the thing is what are all that we need to provide the objective of this particular standard is to provide a overall a fire protection system, effective design and detail about the overall fire protection system. In order to provide the design and detail, first we should know about the facilities. So what are all the facilities which is covered as a part of this fire protection system is explained in this definition, and what are all the fires, what kind of fires can be expected out of this facility, that is also defined in this definition. And what are all the materials which can be exposed to this particular fire. If it is a hydrocarbon material, what are all the types of classification of hydrocarbon material is also detailedly defined in this particular standard. And if that particular, because this petroleum products or hydrocarbon products are classified based on the flashpoint, if you are storing a particular chemical under particular condition, if it belongs to a particular class, and if due to some reason if it is heated up beyond the flashpoint, so in what category it falls. So all this kind of the definitions are detailed in this definitions. So class A means if a material of hydrocarbon falls with or otherwise below this flash point of 23 degrees Celsius, then this particular hydrocarbon is classified as class A hydrocarbon. If it falls between 23 to 65, then it is class B hydrocarbon. If it is falls between 65 to 93, class C, then 93 and above, it is excluded petroleum. And if it is like LPG gas, if it is a liquefied LPG gas, it is a separate category. So this is one point. And second one is classification of fires. So what are all the fires which is classified under this definition is like class A fire. If a fire material which is like a combustible material, and if it is like wood, paper, rubber, and all those things, and which requires a cooling effect to extinguish it, cooling water effect to extinguish that kind of fire, those kinds of fires are classified as class A fire. And if it is a flammable liquid, if it is a flammable hydrocarbon liquid, and if it requires a blanketing effect for extinguishment, then those kinds of fire is called as like class B fire. And if it is a flammable gas, and if it requires a inert gas powder or otherwise vaporizing liquid for extinguishing it, those things are categorized as class C fires. And if it is a combustible metals like magnesium, aluminium, sodium, and potassium, and which requires a specific media or technique to extinguish it, those kinds of fires are classified as class D fire. So next one is fire protection philosophy. So the fire protection philosophy. So what it is like the basics. The fire protection philosophy is like totally based on the loss prevention and control. For example, if a fire breaks out, it has to be extinguished before it escalates to the nearby facilities or adjacent facilities. That is the agenda, or otherwise that is the philosophy or the basis behind this fire protection. So, in order to achieve this, effectively achieve this, the basic design consideration is also provided, and general consideration is also provided inside this OASD. So, with respect to this general consideration is concerned, so it is like saying that the size of the process plant and the temperature and pressure conditions, storage, and this location, all these things has to be studied in detail, and according to that particular part only the basic fire protection system has to be determined. This is one of the main generic point which is mentioned in this OISD. The second one is like the layout has to be in line with or in compliance with this OISD standard 118, which is like layout for fire, oil and gas protection, like refineries, and all those things. So, in order to avoid escalation of fire, so the layout has to be in accordance with this OISD standard 118. And the second, a third major thing which is like what are all the fire protection system which is required is like fire water system, foam system, a clean agent system, carbon dioxide system, dry chemical extinguishing system, detection and alarm system, communication system, firefighting system, mobile and portable firefighting system, first aid and firefighting systems. All these things are required. These things are also considered like provided as a like general consideration inside this OASD. If it is like a design consideration is concerned, like in order to like you have to design this particular fire protection system in such a way that two major simultaneous fires are happening at a particular facility at your plant, anywhere in your plant. Okay, the water which is required or otherwise the foam system or whatever which is required, so that much quantity has to be calculated, and the fire protection system has to be effectively address that kind of two major scenarios in such a way that you have to define this fire protection facility. That is the first and foremost criteria which is described in this design as a design criteria inside the standard. And second thing is like you have to assume that the city fire water supply is not available close to this proximity of this installation. So if you can't able to procure the city water city fire water system, then in such a way that you have to design your system. And it also states that all the tank farm and other areas should be provided with the hydrant system. These are all some of the significant points which mentioned as a part of design criteria inside the standard. So under this design criteria, so it is also states that what type of fire protection system is required on what kind of applicable area. So all this is also outlined. For example, a fixed water fire spray system is required on a storage tank. Storage tank means it's a class A and class B kind of storage tank. Class A and class B with respect to the type of material, hydrocarbon material. So if it is a Class A petroleum storage tank and Class B petroleum storage tank, then a dedicated fixed water spray system has to be provided in line with this OASD 116. And it whatever the distance which is mentioned, like the storage tanks are larger than 30 meters or 20 meters, then only it is required. If it is less than large, like a 20 meters or something like that, fixed roof system, then this fixed system is not required. And if it is like a floating roof tank, if the tank size is like less than 10-30 meters, then it is not required. So semi-fixed foam system is required for storage areas, as described in this description box, like Class A and Class B fixed roof tanks, storing Class A and Class B petroleum products, and Class C petroleum products of size greater than 40 meter. If you are storing Class C petroleum products of tank size more like tank diameter more than 40 meter, then only the semi-fixed foam system is required. Otherwise, only like for Class A and Class B petroleum products only this semi-fixed foam system is required. So similarly, automatic actuated rim seal fire protection system is required for all this external floating roof tanks. And this automatic water spray system is required for all this LPG and hydrogen pressure storage vessels and LPG bottling plant facilities and gantry areas, compressors and pump areas. All this area should be protected with the automatic water spray system. And if this automatic water spray system has to be provided inside this process units, then like the critical process units are also mentioned over here. Like if any vessel is like uninsulated, and if it is having a capacity larger than 50 meter cube, and if it stores Class A and Class B flammable liquid, then this water spray system has to be provided. Similarly, if there's any mobile firefighting or fire hydrant system is not accessible to a particular vessel, then this system has to be provided. Water spray system has to be provided. So for the pipe rack which is handling Class A petroleum chemicals is also has to be provided with this water spray system. and pump handling, like, or otherwise operated above this ignition point is also has to be provided with this water space system. And oil and like gantry areas also has to be provided with this water space system. So there are so many segments are presented with this water spray system. The major components associated with this fire water system are like a fire water pump, distribution, piping network, along with this hydrants and monitors. We have captured under like a very small significant or significant, very less significant points associated in this OASD 116, because it is like describing in detail about the design basis, as well as what are all the flow rate which is required. And it is giving in depth and detail, like what how to perform this demand calculation. It is like detailed in this annexure. Two cases are described in this annexure about the fire water demand calculation and all those things. So those things also has to be like in order to, based on the time constraint and these things, only the gist is presented over here with respect to the design basis is concerned. So as like already stated above, like the fire water system should be designed to meet the fire water flow rate requirement of two major fire scenarios, or otherwise one single largest fire scenarios in case of this floating roof tank is sinking. So whichever is the largest, if you have a floating roof tank, if it sinks, so you have to perform a like a water demand calculation, or otherwise two major scenarios. In that case also you have to perform a water demand calculation, and whichever is the largest, accordingly you have to design your fire water system. So if it is the water, what is the flow rate which is mentioned over here is like the requirement of flow rate and with respect to the applicable area is also described in detail. It is tabulated over here for a quick understanding. Like if it is a cooling tank, then the required flow rate will be like to cool that if there is a tank on fire scenario. Okay, then what will happen is like you need to provide a flow rate of 3 liter per meter square. So if you have a like a tank form, and if the tank if the adjacent tank has to be provided a cooling effect, then if the tank is situated within the like radius of like radius plus 30 meters from the center of the tank which is on fire, then it has that it also has to be provided with 3 liters per minute per meter square flow rate. So if the tank is situated outside of this 30-meter radius, so then it has to be provided only with the 1 liter per minute per meter square. So if it is like a LPG sphere, then it requires 10.2 liters per minute meter square for cooling the sphere of the surface area, sphere surface area. And if it is like within that like a sphere on fire, which is like within the radius of radius plus 30-meter boundary, then it has to be provided with a 10.2 liter per meter square of surface area. All the supplementary system also has to be like provided with a water flow rate of like a 372 meter cube per hour. This flow rate is described in detail inside this OASD 116. So all the other topics which is mentioned inside this fire water system is like about the header pressure. Just only one point of the header pressure is captured over here. The fire water network shall be kept pressurized at a minimum of 7 kg per centimeter square gram at all times. So this has to be ensured. And second thing is like storage and makeup water. So storage and makeup water detail is also like described in very detail. So with respect to the storage is concerned, so the effective capacity should be like of the reservoir or above the level of the suction point shall be a minimum of 4 hours aggregate working capacity of main pump. Okay, if you have this makeup water system, from if you have a provision to take water from this ETP process cooling water, rivers and ponds and all those things, then the supply should be like a makeup water supply is 50%. Then the storage capacity can be reduced to 3 hours aggregate. So if this provision is available, then the storage capacity can be aggregated to like a 3 hours, or otherwise you have to like ensure a storage capacity in such a way that when your main pump is running for 4 hours. So this is the requirement which is mentioned in this OISD 116. With respect to this fire water pump is concerned, there are three types of pumps are mentioned in this OISD. One is like main pump, standby pump, and jockey pump. All the three is mandatorily required. So main pump means the types of the main pump which can be provided are: one is like electric motor driven centrifugal pump, otherwise a diesel driven centrifugal pumps. So, and the capacity which is required is like each pump shall be capable of discharging 150 percentage of its rated capacity at a minimum of 65 percentage of the rated head. Rated means rated capacity, and rated means design capacity and design head. And generally, fire water pump is allowed to operate beyond the design condition. That is why it is mentioned like that. So then the capacity of each pump should not be less than 4 meter cube per hour flow rate, or it should be more than 1000 meter cube per hour. So this is one of the significant point which is also captured under main pump. Then the standby pump, you need to calculate the number of standby pump based on the total fire water demand calculation. If your total fire water demand calculation is like deriving a one main pump or two main pump, then the same amount of standby pump has to be procured or provided. If it is like less than, like more than two, then half percentage, 50 percentage of the standby pump should be provided. If it is jockey pump, then the significant point which is mentioned in jockey pump is like the fire water network shall be kept pressurized at a minimum of 7 kg per centimeter square gram. This is the main like objective of the jockey pump, and this jockey pump will ensure this particular pressure. So it is required to provide one or otherwise one plus standby jockey pump. With respect to the distribution network, the point which is keenly captured is like the firewater distribution ring should be sized for 120 percentage of the design water rate. So this is the most important point. And the firewater network should be designed in such a way that it is in closed loop as far as possible to ensure multi-directional flow in the system. So this is one of the point. And whenever firewater demand increases, then you have to perform the hydraulic analysis. So then you have to withstand whether your distribution network is adequate or not. So for which you have to, whenever you are going for a modification or expansion in your facility, then you have to perform a hydraulic analysis to check the adequacy of the existing distribution network. Then this points which is like captured under this hydrants and monitor is like, if you have at least one hydrant post should be provided 30-meter away from the hazardous area. That is the main point. And second point is like a minimum of two monitors shall be provided for the protection of the cluster of columns, heaters, gasifiers, and etc. The monitors should not be installed less than 15 meters from hazardous equipment. These are all some of the major points. And with respect to this fixed remote or manual operated high volume range water cum foam monitor is like this high volume range water cum foam monitor shall be provided under this tank farm area. Then this inaccessible areas, inaccessible columns, reactors, compressor house, in the units like critical units like CCRU, DHDS, HCU, hydrogen, FCCU, DCU, CDU, etc. And for all the critical equipments which is located higher than or otherwise elevated above 45 meters, also to be provided with this high volume range water cum foam monitors. I think I have captured some of the key points with respect to this fire water system. So with this, chapter, section 5 is completed. There are totally 24 sections along with this reference sections. So first four sections are like general sections, and fifth section only described in detail about this fire water systems. So this particular section itself is having like a subsection of with respect to the fire water system itself, what are all the components of this fire water system. and what are all the flow rates which is which is required, and what are all the major design requirements with respect to this fire water system is also is detailed very clearly in this OSD 116. So if you refer into it, you can go through it, you will get a brief idea about it. So whatever we have described is like to just provide an insight into this particular fire water system. So with this chapter 5 is over. Then the, then what we are going to see is about a fire water spray system. So where this fire water spray system has to be provided, it has to be provided in all this high hazardous area where intermediate application of water is required. For example, if it is an atmospheric storage area, then this fire water spray system has to be provided. So if we have described before, the flow rate condition is the same flow rate condition. If it is to provide the shell cooling, then or if any tank is on fire, then it has to be provided the on the tank shell area, then 3 liter per minute per meter square is required. So if it is has to be provided for the nearby tank, which is situated 30-meter away from the radius of the center of the tank which is on fire, then the same 3 liter per meter square is liter per minute per meter square is required. If it is beyond this R plus 30 meter, then 1 liter per meter square is minute per meter square is required. So, with respect to this atmospheric storage tank is concerned, if it is with respect to this LPG tank truck area or gantry area or wagon area or pressure storage vessels or columns, then 10.2 liter per minute per meter square is required. So, if it is for pump, which is handling this volatile product, and if it is for pipe rack and LPG pump house area, then the flow rate is little bit higher. The requirement is mentioned 20.4 liter per minute per meter square is required with respect to this fixed water spray system is concerned. Then this sprinkler system. Now we are moving on to this fixed water sprinkler system. The key points which is captured under this fixed water sprinkler system is sprinkler systems are used for fire extinguishment, especially inside this car parking in the basement as well as buildings or sheds. So these are all the areas which has to be provided with the sprinkler system for sure. Then the if it is a car parking area, the design flow rate, the maximum design flow rate which is mentioned over here is like a 100 meter cube per hour to maximum of 200 meter cube per hour. If it is for other areas, if the sprinkler system has to be provided with other areas, then it has to be provided the maximum design flow rate is 150 meter cube per hour and maximum of minimum to maximum of 400 meter cube per hour. So this is the criteria which is mentioned with respect to this design water flow with respect to this fixed water sprinkler system is concerned. Okay. So next we are moving on to this foam systems. So for combating large hydrocarbon fire, uh, foam systems are the most effective way of extinguishing system. So especially this aqueous film foaming system, aqueous film foaming foam compound is typically superior when compared with the other foam components. Compounds. So there are two, three, four foam components are described in this OISD 116, which is detailed in this annexures. So if you go through it, you can able to get what types of foam compounds are present, and among that foam components, what are all the conveying depends upon the conveying system how it is categorized, and with respect to the requirement of pressure, this how it is categorized as low expansion and medium expansion foam systems. All these things are detailed in this annexure, in the annexure 8, if I'm right. So if you go through it, you will get a detail about this foam system. Some of the key points with respect to the conveying system is captured over here is like there are three types of conveying system. One is like a fixed conveying system, semi-fixed conveying system, and mobile fixed conveying system. So in general, if storage tank is concerned, the semi-fixed fixed foam system is applicable. So this floating roof tank, this fixed roof tank and floating cum fixed roof tank. In all the areas, the semi fixed foam system is applicable. With respect to this fixed roof tank is concerned, when compared with the floating roof tank, almost all the criterias which is required for this floating roof tank, same thing is applicable for this fixed roof tank. Only one thing which is like a variable is like that whatever the vapor seal chamber is required, so it has to be like discharge before the foam discharge outlet. That is the criteria which is mentioned. Otherwise, whatever the criteria which is required for this floating roof tank protection is applicable for fixed roof as well as floating cum fixed roof tank is concerned. So, with respect to the semi-fixed foam system is applicable. So then the major point which is like mentioned over here is like depends upon the tank diameter. So the minimum number of foam discharge outlet is also mentioned over here. If it is a tank of like greater than 45 to 50 diameter, then minimum of 10 number of foam discharge outlet is required. That is also captured over here. And the estimation of foam discharge outlet is based on pourer capacity. The pourer capacity is should be like 1,000 liter per minute at a pressure of 7 kg per centimeter square uh, gram. So that has to be like mentioned. This is the criteria which is mentioned with respect to this fixed roof tank. Okay. So for floating roof tank also almost a similar criteria is mentioned. With respect to this dike area and spill areas and other areas, so portable monitors or medium expansion foam generation system is required, or foam hose streams are required. So these has to be provided for the dike area, spill area, or oil separators. Okay. So now foam application rate. With respect to this foam application rate is concerned, if it is a cone roof tank containing liquid hydrocarbon, then the foam application rate shall be at least 5 liter per minute per meter square of liquid surface area of the tank. If it is a floating roof tank containing liquid hydrocarbon, then it should be like at least 12 liter per minute per meter square of seal area with foam dam height of 600 of the tank. So this has to be ensured. If the floating room sinking case is considered, then the flow rate requirement should be like 8.1 liter per minute per meter square. These are all the things which is like majorly captured over here. With respect to the duration of discharge is concerned, if a tank is like class A product, then the duration is like 30 minutes. You have to supply foam for 30 minutes. Then if the tank contains class A and class B petroleum liquids, then the duration of foam requirement is like 65 minutes. If where the system primary purpose is like for spill fire protection, so in that case, duration of 30 minutes foam system has to be provided. All these things are mentioned in detail in this under the heading called foam system, which is chapter 6 of this OISD standard 116. You can refer it. So then the main thing is like a foam quantity requirement. If it is like a foam compound, then 20 to 30 liter capacity or 200 to 210 liter capacity in case of like a protein, fluoroprotein or a AFF foams are required. It has to be stored in a container. Then if the foam components can also be stored in a like a overhead storage tank also. And in case of like emergency, this can be like quickly filled using this foam tender or otherwise foam nurses. So these are all the major things which is mentioned in this OASD with respect to this foam compound storage is concerned. So with this chapter 6 of this OASD 116 is completed. There are like 23 chapters which is detailing about other firefighting systems, and like 24th chapter is a reference section. So we are moving on to the next of the sections. I just outlined only one for sections of this other systems. If it is a carbon dioxide system or otherwise if it is a clean agent system, okay. So the carbon dioxide system is required for this turbo generator enclosures and gas turbine enclosures in line with this OASD standard 173. This OASD 116 is asking to refer OASD standard 173 with respect to this fixed CO2 system is concerned. So it is like a fixed CO2 system is like applicable for this turbo generator enclosure and gas turbine enclosures. If the system has to be, then the same fixed CO2 system should be designed and installed in accordance with this NFPA 12. So all these things are the minimum or otherwise mandatory requirement which is stated in this OSD 116 with respect to this carbon dioxide fixed system. If you are like installing this carbon dioxide fixed system, then you have to refer this OSD standard 173 and NFPA 12 with respect to this turbo generator enclosure and gas turbine enclosures. With respect to the control room is concerned, a clean agent protection system has to be provided for this control room, SRR, as well as this computer room. So, and those clean agents has to be provided or otherwise has to be provided in line with this NFPA standard 2001. So in order to provide this clean agent, you have to refer this NFPA standard 2001 also with respect to this control room is concerned, and other computer rooms are concerned. Why? Because this control room and these things are provided with a clean agent because it is handling kind of like a plastic kind of material and electrical wires and cabling. So where water is not suitable, this kind of protection system also has to be provided. As I stated earlier, so it depends upon the type of the fire protection system or otherwise the extinguishing system has to be chosen. So for choosing the type of the fire and sorry for identifying the type of the fire and for choosing the right extinguishing system only this particular OASD 116 is like presented over here. Now moving on to the other firefighting equipment, which is like stated in this OASD. So the other firefighting equipments, like one of the modernization plan for this firefighting equipments is like a rapid intervention water mist cum compressed air foam technology is mentioned over here. Before which, like a dry chemical extinguishers is also required. Where this dry chemical extinguishers is required is like 1 minute. Yeah. So this like chapter 9 or otherwise section 9 of OSD standard 116 details about this like dry chemical extinguishing system. So where and all this dry chemical powder extinguishing system is required is like wherever you are handling these electrical hazards or otherwise a combustible solids like naphthalene or otherwise a pit with melt whatever may be the like if there is any solid bit which is like which can able which has a tendency to melt, all these areas has to be provided with this dry chemical extinguishing system. And if it is a class A, class B, class C and class D fire multi-purpose, then in that area also this dry chemical extinguishing system has to be provided. These are all some of the other firefighting equipments has to be provided in line with this OASD 116 depends upon the type of the fire. So then, according to the requirement of this dry chemical extinguishing system, the design, what are all the system requirements like flooding, whether it is a local application system, whether it is locally applied, or otherwise, whether it is like has to be provided as a total flooding system. All these things are also little bit outlined in this OASD 116, but it is asking to refer NFPA 17 for the limitations and precautions for to refer this dry chemical powder equipment. So you need to refer this NFPA 17 with respect to this dry chemical powder extinguishers. So these things are like outlined in this chapter 9. With respect to this chapter 10 is concerned, that is like modernization plan for firefighting equipments. So modernization plan means either by rapid intervention or otherwise water mist cum compressed air foam technology. So in addition to this conventional firefighting extinguishing system, this foam system, carbon dioxide system, DCP system, all these things has to be provided. So with this trolley mounted water mist compressed air foam technology or otherwise a backpack or portable. So where these kind of this additional or otherwise water mist compressed air foam technology has to be provided is the critical locations which handles hot pumps, which is like the pump which is handling ignition temperature higher than the auto ignition temperature, like wherever the column bottoms, CDU column bottoms, VDU column bottoms, and coker unit columns, bottom pump, and FCC unit bottom pumps, column bottom pumps, and HCU units column bottom pumps. All these areas, there may be a probability of handling of auto ignition, temperature pump, which may handles above this auto ignition temperature. So in all these areas, so we can provide this water mist cum compressed air foam technology along with the conventional extinguishers like foam, carbon dioxide, or DCP. Then the following other equipments, other than this extinguishers which is provided, are like case to case basis. You can provide a thermal imaging camera or otherwise a personal protective equipments. So what are all the personal protective equipments which can be provided here is like water gel based blanket, fire proximity suit, SCABA, airline breathing apparatus, self safety helmets, fire helmets, stretchers, first aid boxes, rubber hand gloves, canister can also be provided along with this firefighting equipment. So and other equipments like portable detectors, then like oxygen meters, hand operated sirens, red and green flag for fire drill. Like in case of fire drill is there, then you can provide flag and all those things. Ladder, emergency lighting, portable megaphone, like leak plugging gadgets, oil dispenser. All these things also has to be can be provided on case to case basis. Like if your refinery, if your critical facility requires these kind of other equipments, you can also provide it. So along with the systems or along with the firefighting equipments, which is like stated above or before. Now we are moving on to the mobile firefighting equipment. So the mobile firefighting equipment outlined in this OASD is like a fire tender. About fire tender, it is like a stated. So in general, three number of foam tender, out of which two are for firefighting. One is like spill or otherwise standby has to be provided. So and the capacity also mentioned over here, like 2000 kg capacity each with nitrogen. So that capacity is with respect to the system is mentioned over there in this OASD 116. So along with the fire tender, some other mobile firefighting equipment which is mentioned are like a trolley mounted water pump foam monitors, foam nurses for filling the foams, and portable or trailer fire water pumps also has to be provided on case to case basis. So these are all, so where it is required and what capacity it is required and how many numbers it is required. All these things are stated in this under the section 12, which is like mobile firefighting equipments. So now we are moving on to this storage of firefighting agents, which is chapter 13 or otherwise section 13. So with respect to the storage of firefighting agent itself is concerned, a detailed table is provided. So what type of firefighting agents, if it is a dry chemical powder, so what capacity it has to be provided according to the storage facility and requirement is fully detailed. Similarly, if it is like a siliconized potassium bicarbonate, so what kind of minimum charge is required. So some kind of criteria are mentioned in tabular format inside this OASD 116. So the major significant point with respect to this larger tank diameter is concerned. So what it is like, in if you have a largest tank diameter, then which is like less than 60 meter, then what else is like a foam quantity requirement should be provided in a distance which is less than 60 meter, and it has to be calculated in line with this OASD standard 117. So you have to refer OASD 117 for providing this for getting more details about this particular foam compound is requirement. So all these things are stated in this table under the section like a storage of firefighting agents. So if you go through this table, which is present in this OASD 116, you will get a more detail about the what are all the other significant criteria with respect to each and every agents. So as of now, we have seen about what is the fire water system requirement, then foam system requirement, the hydrant system, and all those things. All these things. Now we are moving on to the next fire protection system, which is like detection and alarm system. So other than the hydrant and monitors, other than the foam systems, other than the extinguishers, the one more fire protection system is like a detection system and alarm system. So what are all the areas which requires this hydrocarbon detection systems, or otherwise a flame detection system? There is no such criteria for with respect to this flame detection system, whereas with respect to this hydrocarbon system as well as this smoke and heat detection system, some criterias are mentioned. Okay, with respect to this detection and alarm system is concerned, so this the major critical areas which is mentioned over here which requires hydrocarbon detectors are like, if you handle a light hydrocarbon pump, then you need to mandatorily need to provide this hydrocarbon protection system. Okay, like detectors need to be provided wherever this class A materials, class A pump is there. So there you need to provide. Then process cooling tower top platform, so there also you need to provide wherever this pressurized return line, cooling water return line, near the cooling water return line, you need to provide one hydrocarbon detector. And fuel gas knockout drum, adjacent to this fuel gas knockout drum also you need to provide one hydrocarbon detector. So suction side of forced draft air blowers. So wherever these hydrocarbon vapors are present, so near that area with respect to this blowers, air blowers, you need to provide. So light hydrocarbon pump station near this, there also you need to provide this hydrocarbon detectors, like near the grade level. If it is located, if this pump is located below the grade level, then also there also you need to provide this hydrocarbon detectors. In all the LPG handling areas, if it is a hot and spear area, if it is a pump house area, if it is a bulk truck loading area, wagon loading area, bottling area, storage areas, all the areas needs to be provided with this hydrocarbon detectors. And gas compressors also needs to be provided with the hydrocarbon detectors, especially control room. So air intake of the control room in line with this OISD standard 163, hydrocarbon detectors are needs to be provided. Along with that, wherever this tank dike areas, like the class A tank is there, class A material type tank, then the tank dikes and manifolds, pump house and manifolds also needs to be provided with this hydrocarbon detectors. With respect to this smoke and heat detector is concerned, so this has to be provided in along with the other suppression system, like near the LPG spheres, LPG filling sheds, and LPG pump or compressor area, and LPG loading or unloading gantry, as well as tank wagon gantry. All these areas has to be provided with this flame or heat detection systems, or otherwise, if required, very rarely, smoke detection system also has to be provided along this area. Then moving on to the next way of like a protection system, which is like a communication system. So, what are all the types of communication system for an effective communication in case of emergency is outlined in this OSD 116. One is like the first predominant one is like telephone. So it states that control room should be provided with two number of internal phones. One is exclusively for attending only this fire emergency call. Okay, this is like stated very clearly with respect to this telephone communication system is concerned under this control room. So then, if it is like ARP means air raid protection system, so has to be provided in the control room of fire station. Then this detail of group communication system or otherwise alphanumerical pager system should be considered for group emergency communication. You can also provide this paging system for group emergency communication. So then fire sirens also has to be provided, walkie talkie, wireless or wire, both also has to be provided. If it is a small fire, then no siren code is required. If it is a like major fire, a wailing siren for 2 minutes has to be provided. If it is a disaster, then a siren for with major fire will be sounded for 3 minutes with an interval of 1 minute. These are all the siren codes which is mentioned under this communication system. So if it is all clear, if there is no fire and all those things, then straight run siren for 2 minutes has to be provided. Once the fire is over, Then a straight run siren for 2 minutes has to be provided. So walkie-talkie and other fire alarm system also has to be provided. So a conventional type fire alarm system has to be provided, and it has to be provided with this so fire and gas control loop or otherwise logic. So manual call point also has to be provided. So automatic or otherwise gas detection system, smoke detection system, in-bit switches, and all those things. With respect to the detection system, this alarm has to be initiated. Those conditions also stated in this under this heading, which is like fire alarm system under the communication system. With this chapter 15 communication system will be over. So then the chapter 16, which states about the inspection and testing of fire protection system. It is stated that the fire protection system should be kept in good operating condition at all the times. So it has to be periodically tested for proper functioning and logged for record and corrective actions. So the key major timings which is mentioned over here is like if it is a fire water tank or reservoirs, it has to be inspected externally and internally as per this OISD 129 standard 129. So the water reservoir should be emptied out and cleaned once in 3 years. That is the mandatory condition which is mentioned over here. And if it is floating leaves and materials, if something is there, then it has to be cleaned and removed once in 6 months whenever required according to the your own facility condition is concerned. So you need to clean whatever if some kind of leaves or something like that are present as an obstruction. So in order to interrupt the flow, then it has to be periodically inspected and it has to be cleaned. So if it is a foam tank, then it has to be inspected every 3 years externally, and for in under it has to undergo internal inspection. That entire tank has to go for internal inspection every 10 years. So that is also stated under this fire water tank reservoir testing condition is concerned. If it is a fire water pump, then it is stated that it should be tested minimum 2 times a week. Then 1 month each pump should be checked for shut-off pressure and auto shut-off condition. All these things are mentioned under this fire water pump criteria with respect to the testing is concerned. So if it is a fire water ring main, then the all fire main walls should be checked for operation and lubricated once in 6 months for fresh water and once in 3 months if it is handling with saline water or otherwise ETP water. So these are all the testing and inspection conditions which is mentioned with respect to this fire water ring main. So if it is a fire water spray system, then it also has to be tested periodically once in 6 months. For storage tank and for LPG spears and bullets is concerned, it has to be tested once in 3 months if the drill system and all those things are there. Testing of other conditions such as communication system as well as these detectors are also mentioned in this standard. If detectors are concerned, it has to be tested periodically for once in 3 months. The next chapter is like chapter number 17, which is like firefighting organization chart. So a typical chart is for the refinery is provided as a sample. So inside this OISD 116, so the same thing is like captured over here in this PPT. So the fire the whoever is the chief manager, so chief manager fire and safety has to be there. Then the senior manager fire protection should be there, and senior manager from safety also has to be there. Then this senior fire officer from fire and maintenance should be there. Operations also should be there. Safety operation officers and all those people also has to be like a captured under this firefighting organization chart, and they also has to be delegated with the respective actions in case of fire emergencies. So each shift senior safety officer or otherwise a fire operator has to be identified, and they also has to be provided with or otherwise delegated with the actions to be taken in case of emergencies. So Under this organization, one typical point which is captured is like whoever is the personnel who falls under this firefighting organization chart should have a suitable professional qualification, and they should undergo a proper training. So in case of if they are identifying the fires and all those things, they has to be provided with this uniform. All these conditions are mentioned under this firefighting organization heading under chapter 17. So next we are moving on to this chapter number 18, which is like fire protection training. So whoever is the persons stated in this firefighting organization chart or otherwise a fire organization chart, they all should be provided with this firefighting training. Not only those person, all the plant personnel should be provided with the firefighting training in case of yeah, in order to effective proactively work for this fire prevention and firefighting aspects. So mock drills has to be conducted. So the minimum training facility within the refinery should be like it we should have a pan fire simulation facilities, so trench fire simulation facilities, and they should be provided with this fire suit and breathing apparatus. And annexure is stated to mention about the fire fighting ground. So what are all the details with respect to this firefighting ground? So what kind of things, arrangements and everything is mentioned in this annexure. If you go through the annexure in detail, an image is provided or otherwise a figure is provided. So there you will check about the facility requirement with respect to this firefighting ground. It has to be mandatorily provided inside the premises. So then the whoever is the person getting trained, they should be like periodically conducted and like a kind of like a testing or otherwise a kind of mock drill questions also has to be provided for them, so that in order to refresh their firefighting training aspects what they learned. Next one is like mutual aid, which is chapter 19. So refinery or process plant should have a written mutual aid with the similar neighboring facilities. So with under this mutual aid, so all the details and responsibilities of the members, schemes, procedures are all presented, and that is like outlined in Annexure 5. If you go through that, what are all the mutual aid requirements, it is detailed in this Annexure 5. Sorry, 5. Next chapter is chapter 20, which is like fire emergency procedures. So under this fire emergency procedures, it will details it have a very list of like very gist about it. Like each installation should have a like a fire emergency procedures. So in order to develop this emergency response procedure, this PNGRB guidelines is available, which is applicable over here. So, with respect to the standard operating procedures as well as the major hazardous scenarios which is identified out of the plant, so you have to develop a emergency response procedures in line with PNGRB guidelines. Though it is not a mandatory requirement as per OASD, it is required as per this regulation bodies. So, chapter 21 states about this fire station or control room. So, the major thing which is like mentioned over here is like fire station or control room is the most critical important room in terms of fire protection activity is concerned. So, it has to be located in such a way that the control room has to be like wherever this coordinate in all this fire protection coordination can happen effectively. So you have to select a location to build this control room in such a way that you can coordinate in case of emergencies with the entire plant. So this is one thing which is mentioned over here. And communication systems. So, as we stated already, the following equipments should be provided in the control room. One is like we have already seen, it is telephone, wireless sets, walkie-talkie, fire brigade, and fire alarm system also has to be provided within the control room. All these things are stated under this fire station and control room under section 21 of this OISD standard 116. Chapter 22, which states about this passive fire protection measures or other safety measures. With respect to this passive fire protection measures, you have to refer this OASD standard 163. But some of the things which is captured over here in this standard is like Fireproofing is mandatory required for all the structural members, spark arresters, flame arresters, fire separation walls, and this knockout drum impounding basins, fire seals, underground sewer system, lightning arresters, pressurized enclosures, venting facilities, electrical relays, fire retardant coatings for this all this instrumentation cables, and smoke insulation cables. All has to be fire rated, and this electrical enclosures has to be fire rated or otherwise flame proofed. And wherever there is a hot surface, there it has to be insulated. These are all some of the major fireproofing requirements which is listed inside this particular standard. The next is section, which is chapter 23, which is like a fire protection system audit. So what is fire protection system audit? This is the last technical chapter, in view with respect to this audit. So every 3 years internally, once an audit, OASD audit has to be carried out, and the statutory requirements has to be like checked for its compliance or not, in line with the all the applicable OASD standard, not only with fire protection system, all the applicable OASD standards. This is the thing which is stated over there with respect to this fire protection system audit. So the next chapter, which is chapter 24, which is references. What are all the standards which is referred? So NFPA, tax standards, and other international standards, which is mentioned over here, is also captured as a references. With respect to this fire protection system is concerned, one key more point which is mentioned is it requires to refer NBC, National Building Code, for all the other buildings which is present inside this oil and refineries and oil and gas installation is concerned, with respect to this fire protection system, especially with respect to the sprinkler system is concerned. So that's all about this fire protection system. So as an outline, what we have read, or otherwise what we have gone through in this OSD 116 is the objective of this particular OASD is to define the effective fire protection system with respect to the type of the fire and with respect to the type of the facility. So criterias are defined very clearly inside the OSD, though we don't have time to detail or otherwise see the entire thing what it is stated in this OSD. So the criterias are very well defined with respect to the type of the fire and with respect to the type of the facility and with respect to the type of the applicable areas like equipments or otherwise storage areas. So for each and every category, the water system requirement, the hydrant system requirement, or otherwise foam system or any other firefighting system requirement is detailed very clearly. So those things. So totally from chapter 1 to 23 describe all about it. 1 to chapter 4 is like a general topics. From 5 to 23 details about each and every requirement of the fire protection system, including the detection system, communication system, auditing, inspection, everything. So thank you. Do you have any questions?
Am I audible?
Yes, yes, you are audible.
If there's any questions, kindly ask. You can ask in the chat box. Ma'am, I think there's no more questions. We can wind up the session. Thank you for taking the session on a very quick notice. And thank you everyone for participating. You'll be having the assessment of this module on Monday. So if you're interested to take the assessment, please register for the assessment. The link is provided in the YouTube chat box. So you can register yourself for the certificates. We'll wind up today's session. Thank you, ma'am.
Yeah, thank you all, thank you. I think one question is coming.
Yeah, yeah. One question has come. How do
Act gas and fire and
fire
system.
system?
I am not clear with the question. How do fire and gas detection system? How do fire and gas detection system works? See, fire and gas detection system works. If you have a hydrocarbon vapors present inside your facility, then you will be mounting a fire gas detectors over there. So what will happen? It will be connected to your control system. Okay, so it is a dedicated control system will be there for this fire and gas detection is concerned. So with respect to that particular logic, if the detector is detecting any hydrocarbon vapors, then it will give you a it will give you a initiation for activating an alarm. So with that, with respect to that, you will be having an alarm, fire alarm. With respect to the fire alarm, your response action will be defined with respect to this emergency procedures. So what are all the precautionary actions with respect to this fire alarm is taken? For example, any operator can go and inspect which kind of valve or flange is getting leak, or otherwise, if you have two out of two detectors alarm, two out of n alarms, so confirm the gas alarms. In that case, there may be a possibility of configuring a shutdown valve, or otherwise activating any kind of like uh, major fire protection system is also there. All these kind of executive actions will be configured with respect to your control group of this fire and gas detection system. So that's how this entire fire and gas detection system works. I think Abdul, I think I have answered your question. So it's all about instrumentation and logic. Metal fire, what is dedicated OSD? OSD 116 won't applicable. Yes, sir. OSD, this thing is this OSD 116 is describes about metal fire. So it is describing about what type of extinguishers has to be provided in case of metal fire. So as such, it is not applicable. If you go inside detail, the type other agents are also provided over here. So, quartzite bulb, what time break during fire? I think this bulb and all these this detector specification, or otherwise the system specification with respect to each and every system specification, OASD it itself says some kind of vendor data has to be procured. So detailed specification what exactly has to be provided is not clearly outlined in this OASD. What are all the specifications which is outlined is with respect to the flow rate, with respect to the capacity, with respect to the type, and with respect to the numbers. So these are all the factors under the specification, or otherwise are specified in detail with respect to this OASD. Or otherwise the discharge time, or otherwise the time duration which is required for the calculation of fire water demand, all these durations are presented over here. Whereas the specification with respect to a specific component is not outlined in this OASD, that you have to go for the vendor data.
I think there is no more questions. We can wind
I
up,
have
I guess.
noticed I have noticed one comment which I have ran so fast, since because it's a more theoretical oriented subject. So in order to cover all the gist about from chapter 1 to 24, I was just rush up quickly in order to save time. But anyway, if you have any queries in later also, you can text us. Thanks for the
Yeah,
comment. Yeah, yeah.
sure. Also, there is recording will be available on YouTube. So if you have any doubts, you can always come back and see the recording. It is the same link. So ma'am, one more question is there. Fire and gas
Minimum
detection.
value, minimum value with respect to the flammable. I understand it is from based on this LFL level. So that depends upon this company criteria. As far as India is concerned, there is not such defined criteria. Like 20 percentage LFL low alarm will be provided in general, 10 percentage or 20 percentage LFL. High alarm means 45 percentage, sometimes 60 percentage LFL also. This high alarm is provided. LFL is the lower flammable limit for the hydrocarbon vapors is concerned.
Any more questions? Ma'am, one more question is there. What is the
Present
present regulatory? Yeah.
fire safety regulatory in the sense I'm not clear with this question actually. There are regulatory bodies which is like OASD, PESO, PNGRB and other things for fire safety training you are asking, or otherwise
Mr. Ganesh Ramani, can you please ask your question more precisely?
regulatory agencies is concerned is like PNGRB. With respect to fire safety training is concerned, sorry, I was not aware about it. With respect to this protection start, oh no, such. I think the same TRIA is like a same regulatory body with respect to this fire safety. I think you're more specific about this training is concerned. Correct. Any other questions?
Um, no other questions, I think, ma'am. We'll end this. Um, Abdul Sattar is asking some regarding level zero shutdown.
Confirmed gas. Hydrocarbon, since you are saying confirmed gas, it is like we will execute, we can provide an executive action. 2 out of n, 3 out of n. That depends upon the like execute like philosophy which is defined for the detection system. But all these things are not stated in this OISD 116. There is no mandatory like a requirement which is stated in this OISD 116 with respect to all this control logics.
I think there's no more
You want
questions.
to, yeah, if you want to perform a total fire water demand calculation and actually as a given some examples, if you go through it, you can able to understand what is this, how to calculate this fire water demand calculation. OASD is not only guidelines; it's a mandatory requirement.
We'll be sharing the training PPT in the WhatsApp group, so you can go through the PPT anytime. And if there's any questions, you can write us. We'll be connecting with the trainer and we'll be clearing your doubts. Um,
7 kg per centimeter square gram. I
uh,
think
we, yeah,
yeah,
we can wind up the session, ma'am. Ma'am, the other question has come up.
I think all the questions I have answered, ma, until this fire water demand calculation, right?
One more question has come. How do fire farm system work?
How do fire phone system work? Actually, it is like again all this working system and all was not detailed in this OSD 116. If you are like more eager about to know about the working system, I will copy paste one link so that if you go through that particular link, you can able to understand that like form like what each and every fire protection system, how it will work. With respect to the design criteria and with respect to the general requirement is concerned as presented over here in this OSD 116, if you need to know about this fire and gas detection system working, fire foam system working, as well as this hydrant system working, I will separately give you a link so that you can able to go through it, because detailed explanation will be required with respect to this foam fire switching system working on these things and all. It's a normal way. It's a normal, yeah. Yeah, actually, BS standard and NFPA standard is the applicable standard to in order to go through all this details as it is stated in this message. But with respect to the working is concerned, like you need to go for this. I will give you a link. Okay, I will give for all. I will give for all the fire protection system working conditions.
Ma'am, one more question I think has come. Is
Delusion.
deluge and fire
Yeah,
sprinklers?
all this working conditions only. His questions are continuous questions.
Oh, okay, okay, okay,
I
ma'am.
can able to read. Yeah, he wants to know the working system, philosophy for all the fire protection system. So he stated, including deluge and sprinkler system, he wants to do. I will give you a separate link, Abdul Sagar.
Okay, we'll post the link in the chat, in the WhatsApp chat.
Yes, I will give you more so that you can post it.
Yeah, yeah, sure, 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 ma'am.
So shall we wind up? Yeah.
Yeah,
Thank
yeah,
you.
yeah, ma'am. I don't think there's more questions. We'll wind up. Thank you, everyone. Thank you for asking questions. Thank you for your participation. Thank you, ma'am.
Thank you all. Thank you all. Yeah. Thank you. Bye.